Okay, so this is the lesson number Unit 4, lesson number 15, and the learning target. Let's see what are we supposed to learn from here is let's compare exponential functions by studying their graphs. So you will see two graphs, and we will understand where do they meet, at what point they meet, and what is the meaning of the point of intersection. So I can calculate where the two exponential function graphs made using logarithm. So we will use the definition of logarithm to do that, and we will interpret, synthesize, analyze the graphs of two exponential functions in this context. So let's go directly dive down to the practice problem. So let's see. Okay, so I want you to read this and see if you can figure out yourself and comprehend what's given. On the x-axis, it looks like they give you time in years, so that's the input. And on the y-axis, it talks about the revenue. So this y-axis is the revenue in thousands. So this number, when it all say 100, means 100,000. That's all that means. Okay. So let's check. The revenues of two companies can be modeled with exponential function f and g. So there's a f. So let me do this. Blue color. Let's say this is the f graph. Okay. Now this is growing, but we don't know what is the percentage. And also there is a G graph. So there's a G graph here. So this is G graph. It goes up like this. Okay. Now you can clearly see initially we can see what point is that point. So this point we don't know exactly what point, but we do know the pink graph, that is the G graph. The G graph starts at low, maybe at 80. I don't know, but just trying to say maybe 70. Almost 60, I think. Half will be 50 here. So that is 50, and then maybe this is 60 here, I can make. This is like maybe halfway down is 150. So the blue graph starts maybe at 120, right? So this is just my assumption because they didn't give us anything about it. In each function, the revenue in thousands and the time t years is shown. The y coordinate of the okay, they gave the good thing is they gave us this point. So this point is given to us 215.7. So that's the output, the revenue. So the question is what is it? So when does that work? So if we go across this way, I'm going to use the black line here. So if I go across, 215 will be mean. Let me use this. So this is like if we go to the left, the output, this is like 215 right here. That's 215. Okay. Then we need to know how many. So then we go all the way down to figure out. We don't know exactly where, but we can see it is between 10 years and 15 years. If I say this is like almost like halfway down, so I can split this into five parts and say that maybe this number is 12 years. I don't know. So we don't know that part. So the question is, how do we know? So the first question they're asking there is a multiple choice question. This is A, B, C, D, E. The first question is asking the intersection of the graphs tells us when the revenues of the two companies grow by the same factor. Now, look at this part. This one is it is I can even just make my own kind of so the pink graph, okay, the pink graph looks like starts at 60, so I can make my own the g functions. I can say, hey, GTE starts at 60, maybe, I don't know. And then it's growing continuously. So I'll put E raised to, and then we don't even know the rate, but the pink color is growing faster than the blue color. So maybe I'll put it like I'm just making 0 0.0, maybe 0.52. I'll put means it's like 5.2%. And the blue color, I can even just make my own kind of thing. It's going a little slowly. It starts at 120. So the FT here is starts at maybe 120 or 130. And then E raised to And this one is slowing, is slow, right? So see this part, the pink one, and I forgot to put a T right here. This E right here is, I'm gonna make it a little smaller than, so what I took is 0.052 is like 5.2%, right? So I can take that as zero point 0.3, maybe 0.03%, and then times t. So this is how you can create or model the function. Okay, so now the question is they're asking, what does this point is, do they have the same growth factor? So the first part is saying is, do they have the same growth factor? How do we know which is the growth factor is? Now look at this. The growth factor this here is this part. This is the growth factor, which is if you put on the calculator, you get the answer. This will be different from this growth factor. Okay, so this number that you have is growth rate. So please write this growth rate. So that's a two different thing. And you can see this number can never be equal to this whole. So it cannot be the same. So they both have the different growth factor. The pink color is like going accelerating type. It's going faster. The revenue is growing quicker. So this revenue grows faster than the blue one. So if you see in the beginning of the before let's see. So if you see, so if you at this point both point the revenues are the same. So what this means actually is, I don't know what is this point here. Maybe it is 12, but the main thing is this means the revenue for both the blue and the pink is the same. So we say, hey, this point. You say, let me take out this. Okay. So at that point, this point, FT, the revenue of the and GT both are same. If you see on the left side, let's see, before in this area, you can see the blue graph is up. That means FT is greater than GT on the left before 12 years. But after 12 years, you will see the pink graph is above the blue graph. So I put FT, sorry, the GT, the pink graph is higher than so this graph is higher than the FT. So at one point they have the same revenue. The G started slowly, but then gradually it increased faster. And then after the 12, maybe that's what our goal is to figure out how do we find this. We should know at least one of the exponential. Just imagine if we didn't know this part. Okay, I just assume this was not known. Okay, we don't know FT, and if we knew only one of this, maybe GT, let's say. So I hope this you understood. Okay, let's see. Too much of stuff here. Let me take this off. Okay, so this point, if we knew, because you are given the revenue was second output 215.7. Just imagine the pink one is given, right? One of them is, let's imagine, is given. What you can do is you just make the GT is 215.7, and then you got to solve this. That means you just put this GT, this is the GT, because that's where the both are same, GTFT, but they gave us this, right? So you put, okay, 215.7 equals this whole thing which is up here. So if you knew that 60 times e raised to 0.052t, see? And then after that, you just divide by 60 here. Okay, so this will be some number. You can keep it as it is. This goes away, and then change from exponential to logarithm. When I'm saying what does that mean? If you have e raised to x is y, then we say okay, ln of y is x. So that's all. This is by definition of they both mean the same thing, because this basically means logarithm of y to the base e is x. So this one we can change to logarithm form. So we can write down logarithm to the base e of this whole thing, 215.7 divided by 60 is 0.052 and then times t. And then you say, okay, let's divide by 0.052. This also 0.052. And on the calculator, you can easily find it. Sorry, I made a mistake here. So now on the calculator, you will say, hey, that thing is ln, natural logarithm of 215.7 divided by 60 and divide by 0.052, and that's the answer. This will help you that, hey, that after that so many years, so that if you go back the graph, you will get the answer, exact answer right here, whatever that is. We were just assuming, or we were just kind of, anticipating that that's going to be 12, or well, we were, and but now with this thing which we put on the calculator, you should get the correct answer. Hope this helps, and you can see the choices that are there. You have to make sure. So, or they could have given both also. See, the one I started with, the other one was FT. They could have given both. This also. So either both are given, you can figure out where is the input, or one at least should be given. So that's what there will be those questions. You have to decide. Now look at this question they asked here. This is a very beautiful problem, and I really love this kind of questions. Now this talks about the population fast growing cities. That's one going in Texas. There are two, maybe Dallas and maybe Arjo, whatever that is. So there are one city has this part. See, another city is modeled by this. So both are shown with the by just knowing the 82 in the beginning when they measured, and this is in thousands. So the population is showing in thousands. So let me use two colors here. The blue one is the Q. The blue is the second one. Starts at maybe 132. See this 132 here. So this is the QT. So okay. So of course there is a Q right here. And the red one, let's take. And the red one is P. This part it starts at 82. So that's 82. See? This is 82. Starts here, and this is the graph which is growing faster. So the main thing is the idea is growing faster, right? And you will see the reason is if you see this number here, 0.078 is 7.8%. That's the growth rate. And in this case, this part means it is 0.047 is 4.7%. So can you clearly see that this number is lower than this number? What it means is the PET, the red graph, is growing at a faster rate. Okay, so now, so 100% the red one is PET, and the blue one is the blue is the QT. So in the beginning, the population of Q, the blue was more. It was 132. This is 132. So when they measure the population in certain year, oh, in 2016. So this was, what is this basically means? Zero means 216. That's where it starts. And oh, there it is, time in years since 2016. Then this is 1, this is 2, this is 3, this is 4. Basically, this means 2017. This means 2018. This means 2019, and so on. Okay. Now, what the question is, in both equation, T represents since 2016 and the population is measured in thousand. So it's just to show you that T stands for the number of years passed by since 2016. That's what that means. Okay. And the population is in thousands. So whatever, if this is 400, means it is 400,000. Okay. Now the question is, everything is shown. The point where the two graphs intersect, they gave you 217. So this is the point. Okay, is we don't know this part. So I'll put a box, but this is 271.7. So that is given to you. Okay. So the question is, what does the intersection point? Now, in this case, what do you think? Just pause the video for a while and see if you can figure it out yourself. So this point is the both the graph represent the population of the city, right? So at one point of time, that's somewhere here, this point. I don't know exactly after how many years. Is it really three or more than three or less than three? I don't know. But some that point basically means both the population, both cities, the cities you're talking about, they have the same population. This is the population 271.47. So the question is, what does the intersection in this situation means? It only means the intersection is the time when the two cities have the same population done. So you're supposed to write that. What about the second question? Find the x coordinate of the point of by solving the equation. And this is what I showed you for the first 11 minutes. So first equation is the second equation is this. So let me do this. So they're saying this is the y, right? That's the output, the population. This is the input t. We don't know, question mark, right? So when will that? So let me make it nice and clear. It looks dirty here. So there are two parts here. So I want you to write in each case. So let's go back straight away here and put an arrow to show, okay, the first one I want to do, right? So what is PT given to you is the PT was modeled by 82 times e raised to 0.078t, and this time the PT is 271.7. So that's what you have to put this equal. So this is the output. If you want to know when is this population is going to be 271.7, so this is the setup. This is the equation. This is where you set up. And then you start working on it. So the first thing is divide by 82. So both sides divide by 82. So simple. This goes away and you get 0.78t. As of now, just keep this as it is. Don't do no calculation because you're going to change this to exponential form. So when you change this to exponential form, there is a e. So this is the output. So you write ln of the output, which is 271.7 divided by 82 equals, this is the input. The input becomes the output. So 0.078. See, that's all you do all the time. Now divide by 0.078 both sides. And the t, this crosses out. Put this in the calculator and you will get this answer as 15 15.36. 15 point, so after 15.36 years, that population will be 271.7, which basically it means 271.7, and you put 1 2 because you have to multiply by 1000, right? So that's how it is. It is like 271,700. So that will be when it is 15 point. So that takes care of the first one. We can also do the second one. Okay, let's use the second part, this part, right? This time you're going to put QT, and if you see up here, what is QT? You can clearly see that's QT, right? 132. I'm gonna go right down there and write, okay, 132. So it is, so QT is 132 times e raised to 0.477t, and this is equal to, this is how you set it up first. Okay, because this part is qt, so this qt is replaced, and then you do the same thing. Always get away with the number, divide this by the whole thing by 132 this side, this 132 this side, this goes away, and what are you left with is e raised to 0.4, sorry, 0, there's a mistake I did, it should be 0.0479. So this is 0.047, and t times t equals, Now you can find this answer with on the calculator. If you can write on the calculator, that will work out to be, you can put in the best is to write in the 4 place decimal. So using the calculator, you get that. And now change this to the logarithm form. So how do we write this in the logarithm form is this this output, sorry, this input will be the output, okay? And this E which is there goes as ln of, and this output will be 2.0583, okay? And then you divide by t, this, not t, 0.047. This crosses out, and you get the final answer is this t which you write. So you see this t, so that t equals ln 2.0583 and then divided by 0.047, and you end up getting 15.36. So you put this on the calculator, you get the same answer. So this is how you finish. The last question they ask you is explain why we can find out t value at the intersection of the two graphs by solving. So we can also do another third way. So this is another way to do. This is like really cool, where we can still use the two equation and also get that. Let's do that also. Okay. So what I'm saying is the both population are the same, right? The first one was, if you see the first one is uh, 82 times e raised to 0.078 t equals 132 e 0.047 t, right? So we can use this two equation also and figure out, even though they did not give us, I'm going to show how to do. What you can do is you kind of multiply 132 here and 132 here, and at the same time also divide, I'll use the black color, by this e raised to 0.078 t, and here also e raised to 0.078 t. So that way this 132 crosses out. And I also forgot to, so actually what you are doing is you are dividing by 82 also. There's a 82 up here, so you also divide 1 over 82 this side, and the other side is going to be 1 over 82. So two things you're doing. So because there is 82 here and 132 on the other side, so both sides you are doing dividing by 82, 132, 82, 132. So this 82 goes away, and what you end up getting is this thing crosses out, same thing, and then what you get is, yeah, 132. I would like to make it more easier than what I was trying to show. Remember, you can do like this. A times B is C times D, like this. Let's see. You can always write this. We can write this same as, or let's put it like this. A over B equals C over D. And if you use the cross product, this is A times D is B times C. So if this was given, we can go backward and say, okay, we can take this D, which is right here, this side, and the B, which is here, you can take this side. So the same thing I'm going to do, this E, which is right here, I'm taking this side, okay? And this number 82, I'm going to take it this side. And there's a reason, let's see why. So this will become e raised to 0.078 t divided by 0.04 e raised to 470 equals 132 divided by 82. So I'm using the same undo cross product. The reason is we can use now. See, both this has the same base. It's like if we have a raised to m and a raised to n, it is same as a raised to m minus n. Correct? So I'm gonna subtract this to exponent. So it's going to be e raised to. So let me go this side and write. So this part I'm gonna write here. So it becomes e raised to 0.078t minus 0.047t equals, and the other side, let's keep it is the same. This becomes 132 divided by 82. Okay, then you can subtract these two. Okay, so 0.078, and if you are subtracting 0.047, and if you subtract, you get 130 point, right? So this is going to be 0.031t equals 132 over 82 stays the same, and I don't want to do nothing. And we can change this to exponential because this part is the input. So that input will become output here, 0.031t. And then you change to ln, and this become output become the input 130. And finally, you're going to divide by 0.031, divide by 0.031. Put this on the calculator, and you will see you end up getting 15.36. Haha. So that's how you do this. So this question did not ask, but I really wanted to write so that you really understand three different ways to get the same answer. Okay, watch this. This is another beautiful question. The function f is given by this. See this part? What it basically means, let's put it like this. It starts at 100. Let's put it 100, right? And then maybe when it is 0, if you put 0 here, it is like 100. That's where it starts. And if it is 1, it becomes 300. See, if it is because this will be 3 raised to 1 is 3. So 3 times 100 will be 300. So this is going to be 300. So that's how the point is. And if it is 2, that will be 3 raised to the power 2, which is 9. So 900. So if this is your 300, 400, 500, 600, so it goes something like this. The graph is something like this. See this part? This is what is given to you. Now we need to know which of these five also will meet this graph. Now everything depends on the growth factor. So the in this case the growth factor that we see here, the main graph, the growth factor is the 3. Look at that's important point. This is 3. So it means it is 1 plus the r, where r is 2. That means it is 200%. See, so fast. Or another way to look at it is also, let's see, if this is 3 raised to x, the next one, what is the next one says? First one, do you agree with A? Now in this case, it is 10 times 2.7182. That's the natural number, right? So it looks like this will start from somewhere at 10. So this is like 10, 20, 30, 40, 50, 60, 70, and like that. So if it starts at 10, but the growth factor is 2.718, and this 2.7182 is less than the one that is given 3. See? So that means the one which starts this graph will, maybe it grows something like this thing. And they never touch because the growth factor is only less than 3. It never go. Look at the next one is start at 500. So if this is 300, 400, 500. Okay. But in this example, E is is again here 2.7182, and it is less than 3, right? So what that means is it starts here, but because the growth rate is lower, so let me create, this is gone, right? The first part is done. So the second one is starts at 500, so that's 500. It starts here, and then this growth factor is faster, right? The blue ones. This will be maybe going somewhere. It's going to meet because the growth factor of the this one is e 2 point, which is less than 3. So it has to meet. It has to go slower. The blue one goes faster. See this part. The blue graph goes faster because of that 3. It triples, but the black one goes slower. This is part because it is the growth factor for the this one is 2.7182. So they have to meet somewhere. That's all the point. So this is wrong. So one of the answers, this is correct. What about this one? This e raised to minus x basically means it is 500 and minus means it is 1 over e. See this, it becomes like this. It means 500 is 1 over 2.7182. That's it's like a fraction. This is like a this number is between because the denominator is small. That means the graph. So let this is done. The black is done. Okay, the black is done. Let's go the original one. This is the y, and this part is your. So when you have a fractional base, see this fractional base like e raised to minus, then it decays. The graph is this way. So it goes to 500. Okay, this is the graph, but maybe something like this. So it has to cross. So whenever there's a minus, so this minus e raised to minus x basically means the growth factor is e raised to minus 1. So it's like a fraction. So it goes down. So it has to meet. And that's why this is correct. And finally, what about the next part? So we did now let's see what about this? Again, the same story. It starts at 1,000 no matter what. One if it is 300, 400, 500, 600, 700, 8, 9, 10, 1,000 starts here. But eventually, because this 2 which you see growth factor is less than the E part, E is 2.7182. So it has to, even though it started 1,000, it is lower. It will meet somewhere like this because this triples, but this doesn't triple. This is like 2.718. You're multiplying 2.718. So it has to meet somewhere like that. So this is correct. And finally, what about this 600? Now, if you see this part, oh my God, this is 600 times 10x. And look at this growth factor. And this E is less than 10 because 2.7182 is less than 10. What it means is the new graph starts at 600. So where is 600? Let me take another black color. 600, 300, 400, 500, 600. And it goes quicker. It goes quicker. So it's 10 times. And within one, it becomes more. If this 600, 600 within one become 10 times, means 6,000. It goes so quickly, right? So they'll never meet each other. They'll never meet. So this is how you're supposed to analyze the whatever the given situation of this. So beautiful problem. Hope that helps you. Okay, watch this. This is a beautiful. Another nice question is half-life of nickel 63 is 100 years. The student said an artifact with nickel 63 in it will lose the quarter of that substance in 50 years. So what is the quarter? Means losing 25%, right? That means 75% stays. That's what that means. Let's check it out. So if I make a table like this, and in the beginning, let's say whatever that is, half-life. What is the meaning of that? Means whatever the amount in this one in the beginning, whenever it was noticed, In the beginning, maybe, I don't know, they didn't give me a give. I put it A here. And after 50 years, that means this is 50 years, this becomes 2 here. That's all that means. Oh, sorry, it becomes half of that. So this becomes A by 2. So it means you are multiplying by half. Okay. Now the question is, we want to know like 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 20, 20, 30, 31, 40, 49, and 50. We want to know, uh, so there is one mistake I did, that is because it says in 50 years, sorry, the half life is 100 years. So that's the mistake I did. So this is 100 years. So in 100 years, it becomes half. A by 2 is half, right? So the question is, what if it was in 50 years? So does it lose, quarter, 25%? So that's the question. So in order to really understand this, so from here to here, you lose half. See, what is the meaning of half? Basically means is 0.5. Basically means 1 minus 0.5. That means is 1 minus 50 over 100. So that means you're losing 50% in 100 years, and 50% stays. That's all that means. So true, and make sure you understand this part correct. So when you, this is the growth factor, right? But the growth, I will not say growth here, it's a decay factor. But the decay rate is different, and decay rate is 50%. So if this is 25%, students think that, oh, this is 50 and this is 50. So if this is 50%, the students think that for this one, it's going to be 20, half of that, which is 20. Now, is this correct? So that's what the question is. So let's check it out. Now we have to check first for every 1 year how much is the growth rate. Now in 100 years, the growth rate, sorry, the growth factor in 100 years is half, right? So from here to here is half, right? So you multiply half. But what about every year? We want to know 1 year. See this part? This is for 1 year. So the growth factor for 1 year will be, and that's why I'm using B now, because remember the formula is A times B raised to RT, oh sorry, B raised to T. This formula is where A is what you have in the beginning, and this means is the growth or decay factor for t equals 0, 1, so the unit of one increase of 1, 1, 1 like that. So B in this case, this half is for every 50 years. So if I want to know for 1, it has to be, so it will be the half, the same half, but this time it's going to be raised to 1 over 50. Now, why this is like this? Is because if you go on multiplying half of 1 over 50 times half raised to 1 over 50 times half raised to 1 over 50, like this, you go on doing this 50 times, sorry, 100 times. I mistaken, this should be 100 here. This is 100 because in 100 years, this is 100, right? So that's why I have to divide by 100. So I go back. I'm sorry about that. So this is like, okay, 100, 100, 100 like this. And you do this 100 times. So what will happen is you will get, this is 1 over 100 times 100, and you can really get your half, the factor which we were saying this half, right? So we are right. This is for 1 year. But if you want to know for 50 years, then you have to multiply. Then for 50 years, this new factor will be, the new factor will be, oh, So the new factor will be, instead of this b was for 1 year, right? But for t equals 50 years, so your new factor will be it is half raised to, this one will be written 50 divided by 100, which is half raised to half. And if you put on the calculator, this when you put on the calculator, you get 0.71. This becomes 0.71, which is 71%. That means, what does this means is you lose 100% minus 71%. If you take away, it is 29%. So you lose 29%. So the way the students think is, the students were thinking that in 50 years, see, these students think they lose quarter, 25%. No, it's not quarter. It is losing 29%. That's what the main thing. Such a beautiful question. Hope this helps. Thank you. Now this question is a repetition of Unit 4 lesson number. I think it is lesson number earlier lesson number of 11. Just in case if you missed 11, that's what this means is. What are you supposed to do is, one is estimate, and then you use the calculator. We will do both. In this example, look at this. So it's not difficult. What basically this means is logarithm of 123 to the base 10, right? Now, what all you look up for is, this means it is again logarithm to the base 10 of 110, like this. And this means it is logarithm to the base 10 of 1.1. Let's go to the first one. Now, this basically means how many times do I multiply this 10, how many times to get to 123? Remember, 10 raised to 0 is 1. 10 raised to 1 is 10. 10 raised to 2 is 100. 10 raised to 3 is 1000. Okay, let's really get this part. Or you can even make a table to understand this. It's better to make a table. So let's take off this. Okay, and 10 raised to, I'll put start with here maybe. So if I have a 0 and I want to write 10 raised to x, right? Okay, 10 raised to 0 is 1, 10 raised to 1 is 10, 10 raised to 2 is 100, 10 raised to 3 is 1000, 10 raised to 4 is 10,000, 10 raised to 5 is 100,000, right? So every time you go back, you divide by 10. See, divide by 10, divide by 10, divide by 10. And the next one, when you do here, this is minus is, you divide by 110. That means it's 110. And if I put a minus 2 here, this means again you divide by x, you put it minus 2, so it becomes 1 over 100, which is 0.01, and this is 0.01. Now the question is, we just want to estimate what is this estimate, right? Now 123, if you see, 123 is between this number, correct? So this between, so 10 is less than 123, less than 100. So your answer has to be between 1 and 2. That's all it is. So this number has to be 1 point something. We don't know. If you want to really figure out exactly, we can find it. The next one, so this number has to be, I think I made a mistake again. This should be from more than 100, so it should be here. Let me take this off. So it means 123 is between from here to here, right? So it's 100 less than 123 is less than 1000. So the number has to be 2 point something. So this will be 2 point something. Next one is 110,000. That means 110,000 will be, so the next one, if it is 6 here, it will become 1 million, see? So that means this number 110,000 is, it's like this. So this 100,000 is less than 110, is less than 1 million. Sorry, I'm okay. So this, so that means your number has to be, this number will be between 5 and 6, something like 5 point something, 5 point and something. And the last number is given to you 1.1. If you see 1.1, so from here to here is 1.1. So it's like 1 is less than 1.1 is less than 10. So your answer will be between this 0 to 1. So this will be 0 point something. So that's what you just put some number, that's fine, as long as you know it is 2 point something, 5 point something, and 0 point. If you want to know using the calculator, we'll have to go directly to, let's go to, so the first one is, you can just click here and there's most.com, and it was log of, click here all the way go down, right here, see? So click on log of 10, and inside you just put a number 123, you know the answer, see, 2 point. If you want to know the next one, you do the same thing. Yeah, and here it is again. And this time you put 10, and then inside you put 110. There you go, 5.3. And the last one is again do the same thing. This time, sorry, I have to go here. Put a 10, and inside you put 1.1. Okay, and you got the answer, see, between 0 and 1. That's all it is. So these are exact value. Hope this helps. And this is where you really checks on whether you understand the concept. Here are the two graphs, F and G. So you have two graphs shown, but how do you know which one is what? Now both start at 200. That's a good thing. This is 100. And the first one has a growth factor is of 1.2. The second one, look at this. It's not the way it is shown. This means it is 1 plus 0.2. This means it is 20%, right? So the growth rate is 20%, but the second one is e raised to 0.2. That's the growth rate. So basically the growth rate, this one means it's continuously calculating the every moment. So that means it has to be this one, the one which rises. See this part is, so this is gx, so that becomes the gx, and this becomes the fx. So because this is the growth factor, but the first one, the growth factor is 1.0, and this is going to become bigger number. So what it means is for the function f, if you see this part, this means for the function f, the down one is done every 1, 2, 3, 4 like that. But for the function g, the one g, because there's a e there, look at this e there. So this e makes it doesn't. What does this e basically means? It doesn't do every just 1, 2, 3, but it does every moment little. It's growing faster. It's not just one. It's like 0.1, 0.2, and like that. So that's why you see You see the this one growing faster.